How powerful is the FIM-92 Stinger? Can it destroy all Russian aircraft? When Russia invaded Ukraine in late February 2022, outnumbered Ukrainian defenders on the ground were vulnerable to attack from Russian helicopters, which also had the ability to transport Russian troops rapidly around the beleaguered smaller country. That's why the US and its NATO ally Germany decided to give the Ukrainians a potent weapon that might help even the odds: the Stinger anti-aircraft missile. Has delivered hundreds of FIM-92 Stinger Manpads missiles to Ukraine this week amid its war with Russia. Around 200 Stinger missiles were delivered to Ukraine. Latvia and Lithuania are also sending Stingers to bolster Ukrainian air defense capabilities. Moreover, Germany also announced over the weekend that it will send around 500 Stinger missiles, while the Netherlands said it will provide 200 Stinger missiles to Ukraine. How powerful is FIM-92 Stinger? The FIM-92 Stinger is a portable missile that can be shoulder-fired by a single person or a man-portable air defense system or manpads. The missile can be fired from various positions including ground vehicles, helicopters, and airborne troops. One reason the Stinger is so effective is that it's highly portable and can be launched by a soldier or trained civilian who holds it on their shoulder. Stingers also are used on the U.S. Army's AH-64 Apache combat helicopter as an air-to-air weapon, and they can be mounted on ground vehicles as well. In addition to being versatile, the Stinger missile is also highly accurate because it uses an infrared seeker to lock onto the heat in the engine's exhaust, and will hit nearly anything flying below 11,000 feet, 3,352 meters. It is used for engaging low-altitude threats at up to 3,800 m, and has a targeting range of up to 4,800 m. It has a maximum speed of Mach 2.54, 750 m/s. Once it is fired, the warhead, that has a self-destruct timer, explodes 17 seconds later. The Stinger missile is 1.52 m long and 70 mm in diameter. It has 100 mm fins. It weighs 10.1 kilograms, but weighs 15.2 kilograms with its launch tube and integral sight. How Stinger missiles work. The Stinger missile, officially known as the FIM-92A, is designed to give ground troops a way to deal with low-flying airplanes and helicopters. From the perspective of soldiers on the ground, low-flying enemy aircraft are normally a problem because they are either bombing or strafing, attacking repeatedly with bombs or machine gun fire, doing surveillance work, or inserting, extracting and resupplying enemy troops. Shooting down these aircraft is the easiest way to eliminate these threats. There are several things that make the Stinger such an effective weapon for ground troops to use. It is lightweight and portable. The missile and its launcher weigh about 35 pounds, 15 kilograms. The launcher is reusable. Each missile is a sealed unit that weighs only 22 pounds, 10 kilograms. It is a shoulder-launched weapon, and one person can launch a Stinger missile, although you normally see a two-man team operating the missile. It uses a passive infrared seeker. The infrared seeker can lock onto the heat the target is producing. It is called a passive seeker because, unlike a radar-guided missile, it does not emit radio waves in order to see its target. It is a fire-and-forget weapon, meaning it requires no input from the gunner once it's fired. This allows them to take cover, move to another position, or engage a new target. The Stinger missile includes the guidance, tail, propulsion, and warhead systems. The tail has 4 folding fins that deliver roll and stability while the missile is in flight. The guidance section includes the seeker assembly, a guidance assembly, a control assembly, a missile battery, and 4 wings that provide in-flight maneuverability. The warhead is equivalent to 1 pound, 0.45 kilograms, of explosives encased in pyrophoric titanium. The propulsion section includes a launch motor and a dual-thrust flight motor. To fire the weapon, the soldier aims the missile at the target. When the seeker locks on, it makes a distinctive noise. The soldier pulls the trigger, and 2 things happen. 1. A small launch rocket shoots the missile out of the launch tube, and well clear of the soldier who is firing it. 2. The launch engine falls away, and the main solid rocket engine lights. This rocket propels the Stinger to approximately 1,500 miles per hour, 2,400 kilometers per hour, Mach 2. The missile then flies to the target automatically and explodes. The Stinger missile can hit targets flying as high as 11,500 feet, 3,500 meters, and has a range of about 5 miles, 8 kilometers. This means that the target is an airplane less than 2 miles, 3.21 kilometers, high and it is visible as a shape, rather than a dot, then most likely the Stinger missile can hit it. They are extremely accurate. Stinger missiles use passive IR/UV sensors to track targets. The missiles look for the infrared light, heat, produced by the target airplane's engines and track the airplane by following that light. The missiles also identify the UV shadow of the target and use that identification to distinguish the target from other heat-producing objects. Motion sensing lights use passive infrared sensors. The sensors in a motion sensing light are tuned to the temperature of a human being. When the sensors see a sudden change in the amount of infrared light, they turn on the light. A motion sensing light needs only one sensor. But a Stinger missile needs a whole array of them, because its job is to track the target while it is flying. The nose of a Stinger missile has, essentially, an infrared digital camera in it. This camera might have an array of anything from 2x2, in older designs, to 128x128, in the Sidewinder design, infrared sensors that receive an infrared image of the scene. When the soldier gets ready to launch the missile must have the target visible in roughly the center of this sensor. While the missile is flying, the image of the airplane that it is trying to hit may become off-center on the image sensor. When it does, that tells the missile that it is off course, and the guidance system in the missile must decide how to get back on course. This is where proportional navigation comes in. The missile looks at the angle of off-centeredness and changes its angle of flight proportionally. In other words, it uses a multiplier. If the multiplier is 2, then if the guidance system thinks it is 10 degrees off course, it will change its flight direction by 20 degrees. Then, a tenth of a second later it will look at the angle again, and change again. By overcorrecting this way, it lets the missile anticipate the path of the moving plane in the same way that you anticipate the path of a moving object. If you are a quarterback trying to throw a ball to a receiver running across the field, you would not throw the ball toward where the receiver is, you would throw it toward where he will be when the ball arrives. While the Stinger has proven effective over the decades, the U.S. Army already is searching for a next-generation weapon to replace it. Improving the Stinger. In 2019, the U.S. Army began retrofitting its Stinger missiles with proximity fuses. The technology enables the missiles to destroy drone aircraft either with direct hits or by detonating near them, a capability that was demonstrated in Army testing in 2017. The modified missile offers ground troops better defense against small, agile threats. Variants. FIM-92A is a basic model. It can reach targets at a maximum range of 4 kilometers and at a maximum altitude of 3.5 kilometers. Production of this model commenced in 1981. It is likely that production of this missile ceased in 1983. FIM-92B improved model. Infrared seeker head was replaced by a combined IR/UV seeker. As a result, this missile is significantly more resistant to enemy countermeasures such as flares and natural disturbances. This model also has increased range and altitude. It can reach targets at a maximum range of 4.8 kilometers and at a maximum altitude of 3.8 kilometers. Production of this model commenced in 1983 and ceased in 1987. Some sources report that only 600 FIM-92B missiles were produced. FIM-92C improved model. It has further improved resistance to countermeasures and interference. This missile has more powerful digital computing components. Furthermore, its software could be quickly reprogrammed in order to respond to new types of countermeasures. Its maximum range and altitude are similar to the FIM-92B model. Development of this missile was completed in 1987. The FIM-92C was produced in large numbers. Until 1991, around 20,000 units were produced for the U.S. Army alone. FIM-92D has some modifications in order to further increase resistance to interference. FIM-92E has significantly improved flight behavior. Also, it has improved performance against small targets, such as drones and cruise missiles. Deliveries of this model began in 1995, and almost entire stock of the U.S. Stingers was replaced by this model. FIM-92F is an improved version of the FIM-92E. It is a current production model. FIM-92G improved version of the FIM-92D model. FIM-92H indicates a FIM-92D model that has been upgraded to FIM-92E standard. FIM-92J upgraded version in order to extend service life. Aging components of the missiles were replaced with new ones to extend service life for 10 years. Warhead of this model is fitted with a proximity fuse. It improves effectiveness against UAVs. Air Defense Missile Suppression, ADSM. It is a variant of the Stinger with an additional passive radar seeker. This missile can be also used against radar wave transmitters. AIM-92 Stinger is an air-to-air version, used on helicopters.